So this is the third phase of building my SQL engine from scratch. So today we have built semantic analyzer. So let us first talk about the data structures that we used. In the code you can see the data structure, but try to present in a more simpler manner. Here you see in this diagram, let us first start from catalog. What does catalog stores? It stores the table, a vector of tables, and we have declared a function get table to get the table names, right? And then after catalog we have table schema. Now what does table schema does? It stores table name as well as a vector of all the columns. Now this column itself is of type column schema. Now column schema is a structure. Column schema is a structure of each column. And what does it stores? It stores column name and column type. So that was the data structure that we are using in this project. This stage. Let us go to the semantic analyzer code. So this is so here we have declared two private variables, root, which points to the root node or the select node from AST node, right? If you do not remember, it stores null pointer initially, and our lexical analyzer, it returns the not lexical analyzer, the parser. Yes, parser.cpp, it represents select node, right? To select, so select node becomes the root node here. Select node becomes the root node here. I will also show the diagram. And then we have table schema, pointer to table, which initially points to null pointer, right? Now let us first talk about how we are going to traverse through this data structure. So we knew that SQL follows AST data structure, right? So this is how it looks like. Select is the parent of where, which is the parent of from, and from points to null pointer if from is the last clause, right? After from we can also have order by or group by, but we are not going into that. First we'll only talk about these three portions, these three clauses. So initially AST node points to the select node, and select node is always going to be our root node, right? Here on the right side I have mentioned it. Root node is always going to be our select node. We always start traversal from the root node or select node. So AST point to select node. In our next iteration, we will go to where clause, and in our next iteration, we will go to from clause. So we will loop it until we reach any null pointer. Here in the first loop you can see. So in pass 1, we are iterating all the values of from node. So what does from node actually stores? It stores table, right? So if a table exists, we will assign table, we will assign it to the table value. Now what is table? Table, if you remember, is the table schema which was initially pointing towards the null pointer, right? But if table is empty, we will throw the error that table does not exist. That was it. And here you can see we are again initializing, starting from the root node, and we are searching for where clause, right? So until we do not reach any null pointer, we keep iterating. Here you see select node. If select node star equals dynamic cast AST node. So if we find select node, then what we do? First of all, what does select node stores? Let me show you. It actually stores vector of columns, right? Here you can see it stores vector of columns. So select node stores vector of column. Now we are going to compare the columns mentioned in our SQL query with the columns that all the columns that actually exists in the table, right? So here you can see s dot column, it has only the mentioned columns that are mentioned in our SQL query, and table columns, the table that we created here, the table that we stored here, this table, right? This table contains the original table and all the columns. So here I'm saying that table, this table arrowhead columns, it consists of all the columns that our original table has, and we check for the columns that are mentioned in SQL query represented as COL here, if they exist in the column, if they exists in the column schema. What is column schema? It is represented here as C and it has column name. Let me show you. Here you see column schema has column name. So we are checking that the columns mentioned in the SQL query, if they actually exists inside the column name of column schema. If they exist, we return true, it's great. But if does not exist, we will return the error. Getting back to our third iteration, which is going to be about WhereNode. So what does WhereNode stores? It stores condition, which itself is a structure that stores left value, the operator, and the right value of operator. You want to see? Let me show you. Table condition node. Here you can see our where node is storing condition, which itself is an operator of type condition node, and it is storing three values: left portion of the operator, right portion of the operator, and the operator itself. So we are storing conditions inside where node, but it's not necessary that we are going to use where clause every time, right? In a simple SQL query, like here you can see select name from users, it is valid, it is definitely valid, but it does not has where clause, right? So we need to check first that the left value of condition inside where node, if it is empty, that means the where clause has not been defined. In that case, we simply throw the error that the column does not exist, right? But if where clause exists, I mean the left value of condition inside where node exists, that means the column exists and found becomes true, no error will be thrown, right? Here are all the test cases, you can see them, and I was talking about that bug that nowhere clause exists, right? Here it shows it has been passed. So that was it for stage 3. I'm updating everything on my GitHub X as well as my Medium stories, and now even on my LinkedIn page. So do check them out, stay updated, and see you in next stage, next video. Till then, this is Zulfar signing off.